In the xy coordinate plane, the graph of y is equal to x squared minus kx minus 6, where k is a constant, crosses the x-axis at 2 points. What is the value of k? So we have this equation here, which looks like a quadratic equation, except we don't know the value of this coefficient here, k. In terms of coordinate geometry, I believe quadratics, at least quadratics with a power of 2, are parabolas, but I don't really think you need to know that for the Gmat. In other words, I think here, even though it seems like a coordinate geometry question, we're mostly going to be able to do it using our sort of algebraic knowledge of quadratics. So being able to factor and distribute quadratics is something that you should be able to do backwards and forwards. And so let's see if we can do that here. So we're trying to find the value of k, this coefficient. Statement 1 says for each of the 2 points where the graph crosses the x-axis, so it says these are our 2 x-intercepts, which is also our value when y is equal to 0. The x-coordinate is an integer. So when are quadratic equations helpful? They're helpful when they can be set equal to 0, because then they can be factored, and once they can be factored, it's easy to find our roots, our values, possible values for x, when we know that we're setting them equal to 0. And so so that is what we're saying here, because our x-intercepts are our values for x when y is equal to 0. So let's think about just generically, how do we factor things? So quadratics can be factored like this, where what are a and b? A and b are numbers that multiply to this value here, so in this case negative 6, and sum to this value here, so in this case negative k. So if they are telling us our x-intercepts have to be integers, these values here have to be integers as well. So what are my integers that can multiply to negative 6? So I can have 1 times negative 6. I can have negative 1 times 6. I can have 2 times negative 3. And I can have negative 2 times positive 3. And so what is my k going to be in each of these cases? K will be 1 plus negative 6 here, or negative 5. K will be negative 1 plus 6 here, or positive 5. 2 plus negative 3 is negative 1. Negative 2 plus 3 is a positive 1. So it looks here like I'm going to have a bunch of different possible values for k based on my different ways I can factor this equation. So if I also want to write out all the ways I can factor it, what would this be? So I can have x minus 1 times x plus 6. X plus 1 times x minus 6. This guy here would be x minus 2 times x plus 3. This guy here would be x plus 2 times x minus 3. Like we already said before, these are all going to give us different quadratic equations and different values for k, while still all giving us negative 6 for this guy here. And so if you don't believe me, multiply these all out, and you can see for yourself. So this is going to be insufficient because I got 4 values for k here. Statement 2, the graph crosses the x-axis at 1, 0. So I would say, so what does it mean? I could just plug these numbers in here. So they're telling me when y is equal to 0, x is equal to 1, and I should be able to solve for k based on that. So they're saying 0 is equal to 1 squared, which is 1, minus k times 1, which is just k, minus 6. So in this case, k is equal to So -1, then add 6 to that 5. So that's this guy here. But here, that's the only possible value for k. So this statement here is sufficient, B.